It's asking me for BDC, so this angle here, which is the same as this angle over here. This is a right angle because I've got a diameter, so this angle must be 20 to make a total of 180, so this one's 20 as well. Tangent circle at D meets the line BC. Well, let's draw the tangent to the circle at D. Meets the line BC extended, so let's extend BC at the point T. And we want BTD, so we've got this angle here. So what do we know? Well, opposite angles in a cyclic quadrilateral add up to 180. So if this is 70, this is 110. So this angle here, 110 plus 20 is 130, so that must be 60 degrees. By the alternate segment theorem, if this is 60, then this angle is 60. Now if I look at the triangle BDT, I've got 80 degrees and 60 degrees, so I need another 40 degrees in this corner to make 180. That can't be 60. No, that's 50. Twenty plus 110 is 130, so that's 50. Which means that one's 50. Which means theta must be 60 to make a total of 180. First, give me 12. Outers, -3√2. Inners, well, let's check this, plus 2√2 multiplied by 4 is +8√2. And then last, +2√2 multiplied by -√2 is -4. Put the numbers together, 12 subtract 4 is 8, -3√2 plus 8√2 is +5√2. And let's just put this in the calculator and see what happens. So 10 plus 3√2 over √2 is 3 plus 5√2. Histogram. So I've got heights that go from 0 to 12, 12 to 20, 20 to 24, 24 to 28, and 28 to 40. Their frequency densities are 5 high, 15 high, 10, 20, 35 high, 20, 30, and 10. So the group widths are 12, 8, 4, 4, 12. So the frequencies are frequency density times group width. So 5 times 12 is 60. 15 times 8 is 120. 35 times 4 is 140, 30 times 4 is 120, and 10 times 12 is 120. We're told 360 less than 20, so these add up to 180, which is the same as 360 plants. So whatever is the frequency, I've got to double it to get the number of plants. So total of the frequencies of more than 120 is 380, and then I've got to double that to get the number of plants, which is 760. These two lines meet, so that's when the two equations are equal. Now both of them start with y equals, so they can equal each other, so kx equals n over x. But it's when the x coordinate is p, so it's when kp equals n over p. Opposite of dividing by p is multiplying by p, so I get p squared. Opposite of multiply by k is divide by k, so I get p squared equals n over k. And the opposite of squaring is square root. So p is the square root of n over k. But y is k times x. Y is the q value, when x is the p value. We've now got an expression for p, so it's k times the square root of n over k, which we can write as the square root of n times k. P equals 2q, so p is the square root of n over k, equals 2 times q, which is n times k. Square both sides. Means I get n over k equals 4nk. Multiply it by k. Divide by 4n. And square root. So k equals a half. Factorise. This is the difference of two squares. 2x squared gives me 4x squared, so it's plus 1 and 2x minus 1. That's going to help me with this second bit. Because I'm going to rewrite this denominator as two fractions. I'm going to multiply everything by 2x plus 1. So I get 4 plus 1 over 2x minus 1 equals 6x plus 3. And then I'm going to multiply everything by 2x minus 1. So I'll end up with 8x minus 4 equals 12x squared minus 6x plus 6x minus 3. Quadratic, so it's 12x squared, subtract 8x plus 1. A equals 12, B equals negative 8, C equals 1, X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Gives me one answer of a half and another answer of a sixth.